Hello, this is Olesya Krivoruchko, and welcome to my presentation on computer vision in industrial setting. We're going to talk about history, application examples, how it was built, ethical design, data privacy, suggestions for improvement, and future concerns. What is computer vision? As per IBM, it's a field of artificial intelligence that uses machine learning and neural networks to teach computers and systems to derive meaningful information from digital images, videos, and other visual inputs. Microsoft adds a human component to it, saying that computer vision seeks to replicate both the way humans see and the way humans make sense of what they see. Before going into history, I wanted to share some prehistory, because people have been fascinating with things around us, visual things, and trying to analyze it way back in history, even in Egyptian times. But here I wanted to show you two pictures that I found interesting. One is from 1600s. It's a drawing by Leonardo da Vinci. Use of perspectograph. It's a glass where you would trace the surroundings on the glass, and then when you actually look at your tracing, you will be able to see perspective. And he did not invent this perspectrograph, but he was the one who described it. And a little closer to us, 1930s, Electric Sorting Machine Company introduces world first color sorters. So it sorted beans, and it's quite fascinating. Which takes us to history of computer vision, which originated in 1950s when Gibson was able to develop statistical patterns for recognition of 2D imaging pictures. And later in 60s, Larry Roberts pioneered a 3D geometrical information extraction from 2D views, and you can see it on a picture on the left of his research. We transition to real-world images, like things around us in 70s, and then more understanding of 3D model representations in 78. And in the 90s, we see that machine vision starts to become more common, and already companies introducing machine vision systems, and costs begin to drop. Applications. In computer vision in industrial setting can be used in quality control, object detection and tracking, predictive maintenance, robotics and automation, and safety and security. Picture on the left, you can see there's a green square around the bottle, and it's tracking the bottle and detecting label and quantity just from an image. Quite fascinating. How does it work? Robots use optical sensors like cameras, scanners, vision systems, which are powered by analytical software in the back end for computer vision analysis. the AI. So here I would like to present a very interesting article I was able to find about the use of AI, computer vision in recycling facility. It uses cameras to capture images to create a data set to train a neural network on different products and materials. And as a developer describes some of the challenges that they faced, that it's hard enough to train a neural network to identify all the different types of bottles of laundry detergent. But you also need to consider that they can be folded, torn, or smashed. And you need to present all of those images to your machine learning algorithm so it can learn from that. And now computer vision is not the only thing that is used in recycle sorting. It's only a layer on top. So majority of the recycling is sorted by a lot of methods like fiber screen, gravity magnets. Then you have optical sorters, similar to 1930s sorting machine, but much more advanced. And artificial intelligence is only a layer on top. And the way that the author describes that, its ability to actually make a recycling plant profitable. It's closing that margin, which AI can help to accomplish. And here's a picture of a suction arm which detected a piece of cardboard that was, which is picking up piece of cardboard that was detected by computer vision technology powered by AI. Ethical design is important, but it comes especially crucial in industrial setting where you have human automation interaction and people might be working side by side with robots on the same floor. And it's important part of safety. Bias is also very important thing to address. And here in this example, there was a bias potential discovered in one of the systems. A company introduced a product for industrial safety, which would identify potential hazards in real time, such as when a worker gets too close to a high pressure valve and, I don't know, maybe the valve should shut down. But the research discovered that there is a lack of transparency in this implementation, which raises questions about data privacy and potential bias. And you definitely do not want to have a bias when you're working with high pressure valves and such. From safety on the floor, we're moving to data safety. And here I would like to propose to explore cybersecurity industry standards for information security and see if it can apply to artificial intelligence and computer vision. There are three pillars of information security: confidentiality, integrity, and availability of data. Confidentiality says that only authorized users and processes, which could be AI or robot, should be able to access or modify data on a need-to-know basis, which kind of leads to anonymity, for example. And if you have, let's say you have a robot that is identifying recycling material, does it really need to store an information about worker's face? Probably not. Or face recognition? Probably not. Integrity is a second pillar, and you have that data must be authentic, accurate, and reliable. This kind of coincides with transparency and explainability, where you have to have documentation, event log management, version control, and audit trails implemented so you can trace it back, and data cleanup and maintenance is performed, and then initial data for training is vetted and allows for continuous improvements. Availability is important. Users should be able to access the data, if they do have access to that data, whenever they need to. For example, disaster recovery system. So you should be able to retrieve the data. You have copies of data. Timely access. And another detail is robotics cybersecurity. In 2024, actually there's a trend of integrating edge computing with computer vision, which allows for some really significant improvements to reduce latency and shift on device processing, which helps to secure from data breach and cyber attacks. Suggestions for improvement. Yes, on device processing is great. Specialization of robots will probably improve their performance. Cost and energy reduction for AI system, hardware costs, algorithm implementation and processing, and now is the algorithm implemented? How much energy and resources does it use? And the suggestion for improvement is to have algorithms that use less resources. Future concerns. And I decided to leave this happy lady smiling and laughing because I think that there's always some kind of concern that will arise, known or not known. We are in a developing field that is rapidly developing, and we are finding concerns as well as we're finding discoveries of implementation. Maintenance and calibration is important because systems tend to wear out over time, and changes in lighting, environmental factors. Ethical use of AI is ongoing concern. Everything always needs to be monitored for biases and training data. And another industrial specific challenge that might come up is that industrial environments often have a mix of legacy systems and new technologies. So how AI can fit into that? That would be a question for the future. Final tips and takeaways, always continue improving. And computer vision has a large potential for further improving the industrial setting and manufacturing. These are some references. And thank you for listening to the lecture. This was Olesya Krivoruchko for the class of Artificial Intelligence Impacts and Applications, Bellevue College, winter 2024. Thank you.